Hi, hi, welcome to new video. In this video, I'm going to talk about yarn comparison with the MapReduce one. And we are aware about this, the Hadoop one and Hadoop 2. There are two technology, I can say. They given the concepts for the batch processing and their monitoring and scheduling, right? So quickly we'll see about the yarn, how difference different from the MapReduce one, right? And okay, MapReduce one, Hadoop one, and earlier uses a job tracker, centralized scheduler, and the multiple task tracker execute task, right? The job tracker schedule task monitors progress and handle failures. MapReduce 2, that is Yarn, Hadoop 2, later on Yarn, right? So separates job management into two entities. One is resource manager, another one is node manager or application master. So resource manager basically allocate the cluster resources and the application master basically manages the execution of each job. Then when Hadoop released this Hadoop one like MapReduce one and Hadoop two like MapReduce two, later on they gave the name of this MapReduce two is as a yarn yet resource yet another resource negotiator. Now we will learn about the key differences. The differences are like job scheduling and monitoring. In the MapReduce one, job tracker does both scheduling and the monitoring. But when it comes to Yarn resource manager schedule the job, application master monitor, then and job history and management. MapReduce one, job tracker store job history or uses the separate job history server, and Yarn uses the timeline server to store the application history. MapReduce 2 on Yarn improve scalability, resource utilization, and flexibility compared to MapReduce 1, right? The Yarn equivalent to a job tracker is a node manager. The mapping is summarized like in the table. So MapReduce job tracker, their resource manager, application manager, timeline server, job tracker, here node manager. Slot their container. Okay, Yarn was designed to address many of the limitation of MapReduce one. The benefit of Yarn is like a scalable availability, resource utilization, and multi-tenancy. In conclusion, I can say that Yarn enhances the scalability, availability, resource efficiency, flexibility, making the Hadoop more versatile for modern big data workload. Like now, the next topic is very important topic is scheduling in Yarn. In real world cluster, resources are limited and application must wait for their request to fulfill. The yarn scheduler allocates resources based on defined policies. Yarn provides three schedulers with configuration options. Scheduler options like Yarn offers three types of scheduling offer. These are the FIFO scheduler. In this mechanism, process application first in, first out. Benefit is the simple, no configuration required, but the limitation is like not suitable for shared cluster and large application dominates. Large applications dominates resources. Second is a capacity scheduler. In this mechanism is used to multiple queue with the reserved capacity, allowing different jobs to run concurrently. Pros is like ensure a small job can start without waiting for large jobs to finish, and the cons is may lead to lower overall cluster utilization due to reserved capacity. Okay, third one is a fair scheduler. In this, the dynamically balanced resource between the running job and pros is ensure fair allocation, cluster utilization, and timely small job execution. Cons is small jobs may experience initial delays while waiting for resource availability. So there are one diagram is given. By that diagram, we can learn it properly. So FIFO scheduler, a small job wait until large job complete. Capacity scheduler uses dedicated queue to allow a small job to start immediately. And fair scheduler is like dynamically distribution, like cluster resources based on the job requirement. Further, advanced configuration of a scheduler, capacity scheduler, fair scheduler are discussed for the topic. Okay. So the diagram is between cluster utilization over the time when the running a large job and a small job under the FIFO scheduler, capacity scheduler, and the fair scheduler, right? Observe this diagram. I'm just zoom out this. All three diagrams are available. One by one, let me explain the diagram. So the diagram is telling. First diagram is FIFO scheduler in that utilization and time. The graph is plotted between utilization and time. In that job one submitted, job two submitted, and you can observe that based on the occurrence of the job, the jobs are assigned. Okay. Next, capacity scheduler. Here, based on the job size, job is allocated. Same between utilization and time. Here, QA, QB, based on their storage capacity. Fair scheduler, it's a dynamically allocate the particular, you can say the job based on the requirement. Fair share pool of Q. Capacity scheduler, now we will learn about bit about this. So capacity scheduler configuration, sharing Hadoop cluster along organizational line by assigning each organization a dedicated queue with a specific fraction of a cluster. Capacity hierarchical queue allows further division among the internal group inside a queue. Job follows FIFO scheduling, queue elasticity. Here we have to remember this word Q elasticity in the capacity scheduler. Like a job cannot exceed its Q configured capacity, but idle resources can be used temporarily. No preemption. So queues regain capacity only when other containers complete. Maximum capacity like settings prevent one queue from over consuming resources. Okay. Example queue hierarchy. So you can see root here and in that production 40%, development 60%, and some subjects are given there. Their English like science, their so example configuration capacity scheduler, production gets 40%, development gets 60% of cluster resources. Development can use up to 75% maximum, ensuring production always less 25% reserved. Queue placement, map reduce user map reduce dot job dot queue name. If no queue is specified, the job defaults. Warning, use only last part of a queue name. Example, production, English, not full hierarchical path like root.development.english. And the fair scheduler configuration. This was the capacity scheduler configuration. Now fair scheduler configuration. The fair scheduler ensure all the application gets equal resource share, dynamically resource allocation. There is a figure given. We'll learn about through figure also. Initially, first job gets all resources. When the second job starts, resource split into 50-50%. That's the idea about this particular. Hope it is clear with you all. If third job starts, it again share the users queue like 25, 25, 50. Split it down. Queue and pool are interchangeably terms in the fair scheduler. So again, the graph between time and utilization. Here, job one, job two, job three are allocated. Then QB fair share, QA fair share. Some tasks are allocated based on the First time 100%, second time 25, 50-50, and third time 25, 25, and 50, like that. Okay. Enabling the fair scheduler, the scheduler is determined by the setting of yarn.resource-manager.scheduler class. The capacity scheduler is used by default, although the fair scheduler is the default in some Hadoop distributions such as CDH, but this can be changed by the setting yarn.resource-manager.scheduler.class in yarn-site.xml to the fully qualified class name of the scheduler, org.apache.hadoop.yarn.server.resource-manager.scheduler.fair.fair scheduler queue configuration. The fair scheduler is configured using the location file named fairscheduler.xml that is loaded from the class path. The name can be changed by setting the property yarn.scheduler.fair.allocation.file. In the absence of the allocation file, the fair scheduler operates as described earlier. Each application is placed in a queue named after the user, and queues are created dynamically when users submit their first application. Per queue configuration is specified in the allocation file. This allows configuration of a hierarchical queue like those supported by the capacity scheduler. For example, we can define production and development queue like we did for the capacity scheduler using the allocation file. In allocation file or the fair scheduler, one XML code is given. Okay, so that you just go through. What is that? So question mark XML version equals to version number. These are the always given there. Okay, so let me pause. So here in the form of XML, the allocation file for fair scheduler is listed out, right? So default queue scheduling policy fair slash default queue scheduling policy. Queue name is production. Same way weight is 40 and scheduling policy FIFO. Queue like again development 60 and name is science English like that, and queue placement policy, and then name is specified create false, primary group create false, something this is given, right? So the queue hierarchy is defined using the nested queue elements. All queues are children of the root queue, even if not actually nested. In root queue elements, here each subdivided the development queue into a queue called English and another called science. So queues can have a weight which are used in the fair share calculation. In this example, the cluster allocation is considered fair when it is divided into 60-40 proportion between production and development. The English and science queues do not have a weight specified, so they are divided evenly. Okay, so weight are not quite the same as percentage, even though the examples uses number and add up 100 for the sake of simplicity. We could have a specified weight of a 2 or 3 for the production and development queues and achieve the same queue varying. So this is all about this particular XML code and under fair configuration, fair scheduler configuration. And if you want to more about this, is the some more point listed out. Go through this. You will come to know what exactly this is doing. Now, queue placement. For queue placement, also some codes are listed out. For example, this particular it is actually your syllabus part of queue placement and all. So you should learn these things properly. Yes. So the FAIR scheduler uses rule-based system to determine which queue an application is placed. A diagram is listed out, example is listed out. What is the example? Queue placement policy, in that name is specified, and user, and this is what. So what it will do, the queue placement policy, basically you observe here in the XML coding pattern, element contain a list of rule, each of which is tried in turn until a match occurs. The first rule is specified places an application in the queue. It is specified. If none is specified, or if the specified queue doesn't exist, then the rule doesn't match. And the next rule is tried. The primary group rule tries to place an application in a queue which with the name of user, primary Unix group, maybe Linux C group, I think. Okay. So the default rule catches all the always places application. The queue placement policy omitted the entirely, in which case the default behavior is as if it had been specified with the following: queue placement policy rule name is specified user. In another word, unless the queue is explicitly specified, the username is used for the queue creating if necessary. Another simple queue placement policy is one where all applications are placed in the same default queue. This allows resources to be shared fairly between the application rather than user. So for that, you can see this XML code. It's also possible to set the policy without using an allocation file by setting yarn.scheduler.fair.user as default queue to false, so that applications will be placed in the default queue rather than per user queue. In addition, yarn.scheduler.fair.allow undeclared pool should be set to false so that users can't create queue on the fly. Preemption. The another is preemption, right? So that we should learn about that. What is the purpose of preemption? I think you may know in operating system the purpose of preemption, but let me explain again this topic. When a job is submitted to an empty queue on a busy cluster, the job cannot start until resource free up from the job that are already running on the cluster. To make the time taken for a job to start more predictable, the fair scheduler support preemption. Preemption allows you to scheduler to kill the container for a queues that are running with more than their fair share of resources, so that the resources can be allocated to a queue that is under its fair share. Note that preemption reduces overall cluster efficiency, since the terminated containers need to be re-executed. Preemption is enabled globally by setting yarn.scheduler.fair.preemption to true. There are two relevant preemption timeout settings, one for minimum share and one for fair share. Both specified in seconds. By default, the timeout are not set, so you need to set at least one to allow containers to be preempted. If a queue waits for as long as its minimum share preemption timeout without receiving its minimum guaranteed share, then the scheduler may preempt other container. The default timeout is set for all queues via the default share preemption timeout top level elements, the allocation file, and pre per queue basis setting. Likewise, if a queue remains below half of its fair share for as long as the fair share preemption timeout, then the scheduler may preempt other containers. So I hope you are getting the idea about that. This particular is telling setting default fair share preemption threshold and fair share preemption threshold per queue. Now, delay scheduling is very important topic. You should focus on this. All the yarn scheduling schedulers try to honor locality request on a busy cluster. If an application requests a particular node, there is a good chance that other container are running on it at the time of a request. The obvious course of action is immediately loosen the locality requirement, locate a container on the same rack. However, it has been observed in the practice that waiting a short time, no more than few seconds, can dramatically increase chances of being a located container. So the feature is called delay scheduling, and it's supported for both capacity and fair scheduler, right? Every node manager in yarn cluster periodically sends a heartbeat request to the resource manager by default. 1 per second heartbeats carry information about the node managers, running containers, and the resources available for new containers. So each heartbeat is a potential scheduling opportunity for an application to run a container. When using delay scheduling, the scheduler doesn't simply use the first scheduling opportunity it's received, but waits for up to a given maximum number of scheduling opportunities to occur before losing the locality constraint, right? So I hope this all you came to know about this. And for the capacity scheduling, delay scheduling is configured by setting up the yarn.scheduling scheduler.capacity.node locality delay to positive integers representing number of scheduling opportunity that is prepared to miss before loosening the node constraint to match any node in the same rack. Here, the fair scheduler also uses the number of scheduling opportunity to determine the delay, although it is expressed as a proportion of the cluster size. For example, setting yarn dot scheduler dot fair dot locality dot threshold dot node to zero point 0.5 means that the scheduler should wait until half of the nodes is in the cluster have presented scheduling opportunity before accepting another node in the same rack. There is a corresponding property yarn dot scheduler dot fair dot locality dot scheduler dot rack for the setting the threshold before the another rack is accepted instead of the requested. So all about this topic we had learned about the scheduling process in yarn, and here we learned about FIFO, fair, capacity, and their configuration. And with respect to that, we had gone through delay scheduling, preemption, and these all processes we had learned, right? So I hope this is all clear. Next video will come with the dominant resource fairness. This is another topic that we should cover. Thank you so much for this particular video.